Good day, everyone. Welcome to the Certified Math Majors channel. Now, in this video, I am going to teach you a trick on how to solve classical probability problems involving the probability of getting a particular sum after a certain number of dice is being thrown. Although that's the most classical one, that means that's one of the most basic problems in probability, but the solution is quite long in the sense that you have to list down all the possible outcomes before you can actually find the probability. So the problem comes in if you are now dealing with several number of dice and trying to get the probability of finding a certain sum. So, in order to avoid the usual process of listing the possible outcomes just to get the probability, we now have the so called probability apple. Now, this probability apple that I'm showing here is used when we are finding a certain sum after two dice is being tossed. So you're going to use this using two dice. Now, when you roll two dice, there is basically two numbers. And the lowest possible sum that you can get is 1 and 1 because you don't have a zero on the dice. So the lowest possible uh, sum is 2, and the highest possible sum is 12 because each dice can have six faces. So the other dice is 6, and then the other dice is also 6. That's why you get 12. Now, for each of the sum 2 and 12, there's only one possible way we can get them. Again, we can only get a 2 if the sum of if both of the dice shows 1 and 1. And we can also get the sum of 12 only if both dice shows a 6. That's why the 2 and the 12 in the apple are on the same tick line. And the number of possible outcomes to get a sum of 2 and 12 is just 1. Now, before we continue, we will try to demystify first what lies behind this apple figure. Now, it's an apple to show symmetry. When you say symmetry, these values here or these numbers here will take the same values here. So they are related. Now, there is a number at the center. That's the one that we're going to identify which number should be at the center because you cannot just put any number at the center. So, imagine that the highest possible sum is 12. So there should have been 12 ticks because this ticks here represents the sum. So this is for the 2, 3, 4, 5, 6, 7, so on and so forth. Now there's supposed to have been 12, but again, we only use one tick for 12 and 2. It's because they have the same possible outcome. So out of 12, we just now have 11. But since we don't start with 1 because we can't get a sum of 1 if two dice are rolled, we also take one number. So that's why all in all there are only 10 ticks in here. That's why you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ticks all in all. Now you have to divide all these 10 ticks to get the symmetry. So you have 1 here. So 10 ticks minus 1, you have 9. So 9 is odd. That's why one of them should be here. So the rest is 8. That's why you have 4 here and 4 here. So then label it with the numbers. Again, the numbers would be the sum when the two dice are rolled. So we start with 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That explains why the numbers are in this position. Now, so again, for sum of 2, for getting a sum of 2 and 12, we only have one possible outcome for each. Now let's go to the number of possible outcomes for getting a sum of 3. So to do that, we just simply add 1 here. So 1 plus 1, that's 2. Plus 1 is 3. Plus 1 is 4. Plus 1 is 5. And then plus 1 here is 6. Now, since this is symmetrical, these values here will be equal here. So you will have 5, 4, 3, and 2. So now, the possible outcomes are complete. So we can now find the probability. Let's say, for example, probability of getting a sum of 8. So sum of 8. So this is the 8 here. Possible outcomes is 5. So you have 5. Now there are 2 dice. So the denominator is 6 squared, or 5 over 36. Now, to check if our answer is correct, we're going to do the usual method of listing all the expected outcomes. So sum is 5. You can have 1, 4, and the other one is 4, 1. You can have, I'm sorry, we're doing the 8, sorry. Possible outcome is 8. Sorry for that. So possible, sum is 8. So possible expected outcomes would be 4, 4. You have 5, 3. Then 3, 5. You have 2, 6. And then 6 and 2. So count it. 1, 2, 3, 4, 5. There you go. So our answer is correct. Now, let's try another one. What about the probability of getting a sum that is equals to 3? So sum is equals to 3. You have this one here. So possible outcomes, you have 2. So 2 over the possible outcomes is 6 squared. So 2 over 36. That's 1 over 18. So let's try to list the expected outcomes with using the listing. So let's try. You have sum is 3. So sum is 3. You have 1, 2, 2, 1. And then that comes out here, 2. So this is how you're going to use the probability apple if you're going to find the probability of getting a certain sum after 2 dice are being rolled. Next one. The next probability apple that we have is for the probability of getting a certain sum after 3 dice are being rolled. So, if you have 3 dice, the smallest possible sum that you can get is 3. And there's only one way to get 3, and that is to get 1, 1, 1. That's why you have one possible outcome here. And then, same thing, the highest possible number of the highest possible sum that you can get is 18. That happens if all the 3 dice will give you 6. So there's only one possible outcome. That's why 3 and 18 shares the same tick. Now, the sum is 18. So we have to position the text. The sum is 18. So there's supposed to be 18 ticks. But since 3 and 18 shares the same tick, uh, shares the same tick line. That's why we take 1. That's 17. But again, we started with 3. We can't start with 2, so we take another line. That's 16, and we don't have 1 either, so we take another 1. So that's why we're left with 15 ticks. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 ticks. Now, you have to distribute these 15 ticks all together. Now, you now have one tick here, so 14 remains. So, that means each side will have 7. That's why you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You don't have something at the cleft of the apple. So just 7. So the numbers here shows the possible sum. So you have sum 3, 4, 5, 6, 7, 8, 9, so on and so forth until 17. Now, to get the number of possible outcomes, we just add this by 2. This one here. So this gives you 3. Add 3, this becomes 6. Add 4, this becomes 10. Add 5, this becomes 15. Add 6, that becomes 21. Now, you can't add 7 because a die only has 6 faces. So, we stop with 6. Now, for the 9 and 10, there's a special rule here. Since 6 is a sum of 2 and 4, so we add 4 here. So, this will give you 25 here. And then add 2. So, for the 10, that is 27. So, since this is symmetric, you can have 27. This is 25. Okay. 27. Then this is 25 here. You can, then this is 21. This is 15. This is 10. This is 6. This is 3. So now, after completing all the numbers for the expected outcomes, we can now find any probability involving the toss of 3 dice. So how about the probability of getting a sum of, let's say, let's just have the small number 4. So the probability of getting a sum of 4, you have this one here, 3. So that's 3. So there are 3 dice, so you have 6 times 6 times 6. That's the possible outcomes that you will have. So this is 3 over 216. But we can reduce this. That's 1 over 72. So that is the probability of getting a sum of 4. Now, to check if we really get the correct uh, possible outcomes or expected outcomes, which is 3, let's try to do the listing. So let's try to do the listing for this one here. So we want a sum of 3 after tossing 3 dice. So that could be 1, 2, 1. And that could be 1, 1, 2. And it could be 2, 1, 1. Nothing more. That's why you have 3 here. So this is how you're going to use the apple in solving for the probability problem about getting a certain sum after tossing several number of dice. So thank you for watching, and please subscribe to our channel to be updated on our next videos. So again, thank you so much. Enjoy learning.